Hello students, welcome to AIMSTday online classes. This is a chemist session. Here we are discussing about chemical bonding chapter. In this session we are going to see about coordinate covalent bond or dative bond. It's one of the type of covalent bonds we are going to see here. Before this, let us see the characteristics of covalent compounds. In the earlier sessions, we have discussed about what are covalent bonds, how they are formed, what are the different kinds of covalent compounds, what are different kinds of covalent bonds we have discussed. Now we are going to see about characteristics of covalent compounds. First among them is physical state. Under the normal conditions of temperature and pressure, these covalent compounds exist as either gases or liquids of low boiling points. This is due to the fact that very weak force of attractions existing between the discrete molecules. So because of the less attractions between the molecules, these covalent compounds are mostly existing as either gases or liquids at the lower boiling points. Some exist as soft solids. Some of the covalent compounds exist as soft solids if their molecular masses are high. For example, sulfur, phosphorus, iodine. These covalent substances exist as soft solids, but most of them are either gases or liquids with low boiling points. Okay. Next property or characteristic is melting and boiling points of these covalent compounds. With the exception of a few which have giant three-dimensional structures like diamond carborundum, which is also called silicon carbide, and more silica, which is called silicon dioxide. So these are covalent compounds only, but they have three-dimensional giant structures. So that is why they have high melting and boiling points, even though they are covalent compounds. But except these kind of compounds, other covalent compounds are having relatively low melting and boiling points. This is due to the presence of weak attractive forces between the molecules. So between the molecules of these covalent substances, there are existing weak attractive forces. Because of these weak attractive forces, they have low melting and boiling points. Most of the covalent compounds have low melting and boiling points. But very few compounds such as diamond and carborundum, silica, these substances, they have giant structures. Molecules are clubbed together. They join together to form a giant structures. So to separate these giant structures, they need high temperatures, and hence they have high melting and boiling points. But like this, very few are existing among covalent compounds. Mostly they have low melting and boiling points only. Okay. One other property is crystalline structure. The covalent substances are composed of neutral individual molecules with a weak force between them. Thus, covalent molecules are not closely packed. So they won't exist in the crystalline form. Mostly the covalent compounds you can say they exist in the amorphous forms. However, diamond, silicon carbide, as we told, silicon carbide, silica, aluminum nitride, which are having giant molecular structures. There, so many molecules club together to form giant molecules. So, such compounds, they are having very hard structures and possess high melting points because of the network structures. So these substances, they form giant molecules. So many molecules, they combine together to form giant structures. Because of these high network structures, they have high melting points. Except these, what we told here, examples like diamond, silicon carbide, silica, and even aluminum nitride, which are having giant structures. Except these, most of the covalent compounds, they're having weak forces between the molecules of those. So because of weak forces, they won't be joined together, and hence they will be having lower melting and boiling points, and they do not have crystalline structure. These substances are having Crystalline structure. With silicon means we know sand. It is made up of silicon dioxide. Even though it is a covalent compound, because of giant structure, it is having crystalline structure. Even diamond also. It is purely made up of carbon atoms as we know. Only carbon atoms existing in that. But they exist in the large quantity. They form huge molecules. Crystalline structure they exist. But the remaining covalent compounds, in between their molecule they have weak force of attractions and hence they do not form any crystalline structures. Mostly covalent compounds exist in the amorphous form. Okay, let us see another property. Molecular reactions. Covalent substances they undergo molecular reactions. Means instead of ions in the covalent substances, molecules they participate in the chemical reactions. So during these molecular, that's why covalent reactions are called molecular reactions. So during these molecular reactions, bond breaking and bond making takes place, because when two or more kinds of molecules they combine, first the atoms present in those molecules will be separated. That needs bond breaking, and these atoms rejoin together to form new molecules. Their bond making is occurring. So, thus, in the covalent reactions, bond breakings and bond makings occur. Bond breaking and bond making takes place. So, these reactions are generally, that is why, slow and rarely proceed to completion. So, because of this reason, bond breaking is to be done and bond making also be to be done. That's why these reactions or covalent molecular reactions will be generally very slow, and they come to completion very rarely. They'll be slowly proceeding continuously. That's why, hence, certain catalysts, certain chemicals are used for making these reactions speed up. So, catalysts are used to speed up these reactions. What is catalyst here? The chemical substance which makes the reaction speed up, but it won't be involved in the reaction. The chemical substance which increases the rate of the reaction, speed of the reaction without participating in the reaction is called, the chemical substance is called catalyst. Okay, for speeding up these molecular reactions or covalent reactions, certain catalysts are used because these covalent reactions are very slow. Next, conductivity, electrical conductivity of these covalent substances. In general, covalent substances are bad conductors of electricity, but there are certain exceptions here also. Substances like which are having polar character. What is meant by polar character? We told polarity, existing with a polarity. Even though that bond is formed with the sharing of electrons between the two atoms, one of those two atoms participating in the bond will be more electronegative, and hence it will pull the pair of electrons towards it, and hence light charges are forming. Such kind of molecules are called polar molecules. Example, hydrogen chloride. So the substances which are having polar character like hydrogen chloride in their solution form can conduct electricity, because these polar covalent molecules on dissolving into water they split into respective ions. If you see hydrogen chloride, it is actually a covalent molecule, but it has polar character because of difference in the electronegativities of two participating atoms. So because of this polar character, on dissolving into water, it splits into H plus and Cl minus ions. So because of the existence of these ions, they can conduct electricity. Okay. But covalent solids having giant molecular structures are bad conductors. For example, if you take diamond, it is a covalent giant structural molecule. If it is even it is taken the solution form, if it is dissolved into water, it won't dissolve into water, and hence they conduct no current. That we call these giant structures are bad conductors of electricity. One more giant structure is there, but it can conduct electricity among covalent compounds. That is graphite. The graphite can conduct electricity since electrons can pass from one layer to another layer. Graphite is also made up of giant structures of carbon, but it exists in the form of layers. Out of these layers, there will be certain free electrons in the carbon atoms. These free electrons can pass from one layer to another layer in the graphite. So because of these free electrons in the carbon layers, graphite can conduct electricity, whereas diamond is a poor conductor of electricity. Okay, so mostly covalent compounds are bad conductors of electricity or poor conductors of electricity, but certain covalent compounds are there with polar character like HCl. When these polar covalent compounds dissolved into water, they can conduct electricity because of the formation of respective ions. But mostly covalent compounds are poor conductors. Okay. Next, solubility of these covalent compounds. In general, covalent substances are insoluble in polar solvents like water, but soluble in non-polar solvents like benzene, carbon tetrachloride, and ether, etc. These all are non-polar solvents. They do not have any polarity in their molecules. Such substances are called non-polar substances, and these are used as solvents, and hence they are called non-polar solvents. As covalent compounds are generally non-polar, they do not dissolve into polar solvents like water. But of course, few they dissolve because of polarity. This is based on the principle that like dissolves like. Some of the covalent compounds like alcohol, amines, they dissolve in water due to hydrogen bonding. Okay, here we told this solubility based upon the principle that is like dissolves like. Means polar substances they dissolve into polar solvents. For example, hydrogen chloride is a polar covalent compound. It dissolves into polar solvent like water, and non-polar substances they dissolve into non-polar solvents like benzene. So mostly covalent compounds will be non-polar. That's why they dissolve into non-polar solvents like benzene, carbon tetrachloride, etc. Okay, that means that is a principle which is explained in this. Like dissolves like. Polar substances dissolve into polar solvents. Non-polar substances dissolve into non-polar solvents. And one more exception here. Some of the covalent compounds like alcohol, amines dissolve in water due to hydrogen bonding. Even so, they exist with a certain hydrogen bonding. This is one of the special bonding. The attraction between the hydrogen atoms of one molecule and electronegative atom of another molecule is called hydrogen bonding. Because of these attractions, certain covalent compounds like alcohol, amines, and sugars they dissolve into water. This dissolution is because of hydrogen bonding. Okay, we are going to learn about this hydrogen bonding in detail in further classes. Just we can say here the attraction between the hydrogen atom of one molecule and the electronegative atom of another molecule. So because of this reason, certain covalent compounds dissolve into water. So covalent solids having giant molecular structure are practically insoluble into water. They have no solubility in any solvent. Okay, that's about solubility. Now we are going to see about another kind of covalent bond which is called as coordinate covalent bond or dative bond. A covalent bond is formed by two atoms sharing a pair of electrons, isn't it? One atom will contribute one electron and the other one will contribute one more electron. Hence, this pair of electrons are shared between those two atoms mutually. In that way, covalent bond is formed. The atoms are held together because of the electron pair is attracted by both the nuclei of the atoms equally. Hence, the two atoms are held together and hence the molecule is formed. In the formation of a simple covalent bond, each atom will contribute or supplies one electron to the bond formation. But in some special types of covalent bonds, the shared electrons are contributed by one atom only. We have learned about covalent bond in the previous classes. What we have learned there? How a covalent bond is formed by mutual contribution of electrons. each atom will supply one electron for bond formation. Thus, the two electrons are shared between the atoms and hence a covalent bond is formed. But in certain special type of covalent molecules, certain covalent bonds, the shared pair of electrons are contributed by one atom only, and these pair of electrons are shared by both the atoms. Such type of covalent bonds are called coordinate covalent bonds. Okay, let us see in detail about this. The covalent bond in which both the electrons of the shared pair are contributed by one of the two atoms and shared by both the atoms is called coordinate covalent bond. Such a coordinate covalent bond is also called as dative bond. Okay, a coordinate or a dative bond is established between two such atoms, one of which has a complete octet and possess a lone pair of electrons, while the other is short of a pair of electrons to get octet. So between such kind of two atoms, a coordinate covalent bond can be formed. What are the two types of atoms? One should be having complete octet, and that should have a lone pair of electrons, at least one on its valence shell, and the other atom should have short of a pair of electrons to get the octet. Then if these two atoms if they combine, then a coordinate covalent bond is formed. Representing a coordinate covalent bond. In simple diagrams, a coordinate covalent bond is shown by an arrow mark. The arrow points from the atom which is contributing or donating pair of electrons to the atom which is accepting that pair of electrons. Okay. The atom which contributes or which donates the pair of electrons for the formation of covalent bond is called donor, while the atom which is accepting this pair of electrons is called acceptor. Okay, a coordinate covalent is bond formed between a donor and acceptor. Here we have to understand we have to note one point, that is coordinate covalent bond once after the formation is indistinguishable from the covalent bond. Before forming itself, it is before forming only it is different from the normal covalent bond. What we are telling the difference? Normal covalent bond is formed by the mutual sharing of electrons, in which each atom will contribute one electron for the sharing. Such a bond is called normal covalent bond. But in a special case, both the shared pair of electrons are given by one atom or contributed by one atom only. That pair of electrons are shared by both the atoms. So, in such a way, coordinate covalent bond is a little different from the covalent bond in the formation. But once after the bond formation, it is not at all different from the covalent bond. It is also considered as a covalent only. It is indistinguishable from the covalent bond. Okay. Now let us see some examples here which are having covalent bond. Let us see first the formation of sulfur dioxide molecule. We know sulfur has 6 electrons in its valence shell because its atomic number is 16, and its configuration if we write we get it as 2, 8, 6. So it has 6 valence electrons. In the formation of sulfur dioxide molecule, sulfur bonds with one of the two oxygen atoms by sharing two pairs of electrons, such that it remains with two lone pairs of electrons. See here in the sulfur dioxide molecule, first sulfur atom bonded with one of the two oxygen atoms, the two covalent bonds. So by sharing two pairs of electrons, it formed here two covalent bonds with one of the two oxygen atoms, and it is remained with the two lone pairs of electrons. Isn't it? Now it forms a coordinate covalent bond with another oxygen atom by contributing a pair of electrons for sharing. See here, after the bond form two covalent bonds with the oxygen atom, this oxygen is getting already 6 electrons are there. After the sharing these 2 electrons, it is getting 8 electrons. So it is getting octet configuration. At the same way, if you see this sulfur, already there are 6 electrons in the valence shell. It is shared 2 more electrons from this oxygen. So this got now octet configuration. So it is with the octet configuration, and it has two lone pairs of electrons on its valence shell. And this, if you observe this oxygen, which is not participated in the bonding, it is having vacancy for two more electrons in its outermost shell to become stable with the octet. Now, when these two approach, this sulfur will contribute this pair of electrons for this oxygen for sharing. Now, this pair of electrons shared by this oxygen, and hence it is getting octet. And the sulfur is getting no more electrons, no more extra electrons. So it is being with the octet. Just it is contributing its pair of electrons for this sharing. Okay. Thus a bond formed between these two is called coordinate covalent bond or dative bond. It is represented with this arrow mark. See here, it is shown from the atom which is contributing this pair of electrons to the atom which is accepting this pair of electrons. Once after the bond formation here, it is no different from covalent bond. Okay. Next, let us see one more example. Reaction between ammonia and boron trifluoride. Although the nitrogen atom has completed its octet in the ammonia, it still has a lone pair of electrons in the valence shell, which can be donated. See here, this is ammonia molecule. Even after the bond formation with the three hydrogen atoms, it is getting octet. Even after getting octet also, it has a lone pair of electrons, which can be contributed to some other atom. Isn't it? If we see in the other case, boron trifluoride molecule. In this, boron atom is ready to accept a pair of electrons still, because even after the bond, three covalent bonds formation with the three fluorine atoms, it has deficiency of two more electrons for getting octet. So the boron atom in boron trifluoride is short of two electrons, which can accept two electrons to complete its oxide. So when you club these two molecules, when these two molecules are combined together, nitrogen will donate this pair of electrons to boron, and hence a coordinate covalent bond is formed between these two. Now this is called coordinate covalent bond or coordinate covalent compound. We can say this is ammonia boron trifluoride. Ammonium boron trifluoride is formed by the coordinate covalent bond between nitrogen and boron. In this, donor is ammonium molecule, acceptor is boron trifluoride molecule. Okay. So some other examples for the molecules which are having coordinate covalent bonds. They are ammonium ion, NH4 plus, it is called ammonium ion, and water hydronium ion, H3O plus, it is called hydronium ion, and ozone molecule, sulfur trioxide, etc. These all contain dative bond in them. If you see example ammonia, ammonium ion, NH4 plus. In this, if you see ammonia, just now we have seen in this formation NH3 ammonia molecule. It has octet configuration for the nitrogen, and there is a lone pair of electrons on the nitrogen atom. And if you see H plus ion, how many electrons will be in the H plus ion? Actually, if you say hydrogen, it has one electron. If we say H plus ion, it has no electrons. Only one electron is present on the, no electrons on its valence shell. It has a deficiency of two electrons for getting duplet configuration. Now, when these two approach each other, nitrogen will donate this pair of electrons to hydronium H plus ion, so that they form a coordinate covalent bond between them. Thus, NH4 plus is formed. Okay, in this way, these molecules or ions are also containing coordinate covalent bond among them. Okay, that's about coordinate covalent bond. In this is a donor and it is acceptor. So this coordinate covalent bond formation is represented with this arrow mark like this. In this, it is pointed from the molecule or atom which is donating pair of electrons to the atom or molecule or ion which is accepting that pair of electrons. Okay, once after the bond formation here, it is no more different from the remaining covalent bonds. All will be seen similar. Okay, now let us see The properties or characteristics of these coordinate covalent compounds. One among them is their melting and boiling points are in between the properties of those covalent and ionic compounds. That means their melting and boiling points are higher than purely covalent compounds and lower than purely ionic compounds. These are sparingly soluble in polar solvents like water, but readily soluble in non-polar solvents. So mostly these coordinate compounds will be non-polar mostly. That's why these are readily soluble into non-polar solvents, because we told a principle that like dissolves like. So these coordinate covalent compounds are being non-polar, they dissolve into non-polar solvents readily, but very sparingly, means very slightly soluble into polar solvents like water. Like covalent compounds, these are also bad conductors of electricity. Even these coordinate covalent compounds are also bad conductors of electricity. Their solutions or fused masses do not allow the passage of electricity because they do not form any ions. Even in the aqueous solutions or in the fused solutions, they do not possess any ions, and hence they cannot pass electricity through them. They are bad conductors even in the solution form or fused form also. Okay. And one more point about them is the bond is rigid and directional. So just like the covalent bond, coordinate covalent bond is also directional bond. It is pointed from one atom to another atom because the sharing is between two atoms specifically. So we can say it is rigid and directional. We know ionic bonds are non-directional. So covalent and coordinate covalent bonds are directional. Okay, that's about coordinate covalent compounds. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.